Welcome, Midrand BSc IT students. Okay, let's get right into it. We are here today to really heavy prep for your upcoming supplementary and deferred assessments, which we know are running from September 5th to the 9th. Now, I want you to listen closely because we are focusing entirely on section 17.4 from your textbook, which covers software as a service, along with the overarching cloud architecture key points from chapter 17. I can guarantee you, literally without a shadow of a doubt, that this is going to be a major exam topic. So grab your notes, get focused, and let's get you ready to absolutely crush this assessment. Here is our game plan for today's masterclass. We'll start with an introduction to SaaS. Look at the business shift. Compare SaaS versus SOA. Dive into designing scalable SaaS. Do a Chapter 17 master recap. And finally, wrap up with your summary and exam focus. All right, part 1. Introduction to SaaS. Let's define exactly what we mean here. So the absolutely crucial point is this definition right here. Software as a service, or SaaS, is software that is deployed on a remote server, usually somewhere in the cloud, and you access it through a standard web browser. Think about how things used to be, right? You would literally buy a CD-ROM and install this incredibly bulky software program locally onto your PC's hard drive. Well, not anymore. Today, modern software is hosted entirely remotely. If you're using Gmail, Google Docs, or Microsoft Office 365, well, you're already an expert SaaS user. Moving on to part 2, the business shift. Why is everyone abandoning local software and rushing to the cloud? The business shift is really driven by one beautiful concept, and that is offloading responsibility. When a company uses SaaS, all those massive management costs and IT headaches, they're transferred directly to the software provider. If there's a bug, the provider fixes it. When it's time for an upgrade, the provider rolls it out seamlessly behind the scenes. Furthermore, companies no longer have to buy these massive, incredibly expensive hardware servers just to handle unpredictable spikes in user traffic. The cloud just scales automatically. Add in the fact that there are practically zero software license management costs, and you get a highly flexible pay-per-use subscription model. Well, it's pretty easy to see why businesses absolutely love this approach. However, it's not all sunshine and rainbows. The flip side includes a very heavy reliance on network speeds. If your internet goes down or it's just running slow, your entire business grinds to a halt because all that data transfer has to happen over the web. You also lose control over how the software evolves. The provider might just change the user interface overnight, and, well, you just have to deal with it. Finally, and this is highly important for us locally, there are potential legal issues with storing sensitive data offshore. In South Africa, this relates directly to data protection regulations like the POPI Act. If your cloud provider stores your customers' personal data on a server in another country, you have to make absolutely sure it doesn't breach local privacy laws. Okay, part 3, SaaS versus SOA. We really need to understand the difference here. Before we compare them, let's just clearly define SOA. Service-oriented architecture is an approach to structuring a software system under the hood. It involves building a system as a set of separate, independent, stateless services. Now, stateless simply means each interaction is treated as brand new. The server doesn't keep a memory of your past clicks. It's really a way of architecting the code itself. So let's put them head to head. I'll tell you right now, this is an absolute favorite for examiners, so pay very close attention to this. SaaS is a delivery method. It's how the user actually gets and interacts with the application. SOA, on the other hand, is an implementation technology. It is how you, the software engineers, actually build the system in the background. They are completely different concepts. Furthermore, SaaS typically involves long transactions, like a user logging in and editing a document for 3 straight hours. SOA involves very short transactions, like a piece of software instantly calling an external service to verify a credit card number, getting a result, and immediately closing the connection. Make sure you know that distinction. Let's look at part 4, designing scalable business SaaS, and specifically the big 3 factors. Right, so if you are building software that you intend to sell as a service to hundreds of different businesses, you literally cannot build a unique version of the software for every single client. That totally defeats the purpose. To successfully tailor one generic service to specific business customers, you absolutely must design for these big 3 factors: configurability, multi-tenancy, and scalability. Let's look at each one. Let's break them down, starting with configurability. This is the ability to adjust the behavior of the software dynamically as it is being used, based on the specific user's preferences, all without deploying a different copy of the source code. It essentially allows different companies to feel like the software was custom-built just for them, even though it wasn't. Your textbook outlines 4 specific ways a system can be dynamically configured. First, branding, customizing the user interface with the client's logos and corporate colors. Second, business rules and workflows, allowing the customer to define their own internal processes right within the app. Third, database extensions, letting the customer add custom data fields that are specific to their industry. And fourth, access control, allowing the customer to create distinct user accounts and define exactly who gets to see what resources. To really illustrate that concept, look at this setup. Notice how we don't have separate applications. We have one single application service sitting at the top. Multiple users interact with that service through specific customer profiles, profile C1, C2, and C3. Those profiles basically act as a lens. They contain the configuration rules that dynamically change how the software looks and behaves for that specific employer. It's super clever. Okay, our second big factor is multi-tenancy. I'm explaining this loudly and clearly for the exam, so highlight this in your minds right now. Multi-tenancy is a situation where many different customers, which we call tenants, use the exact same software application and share the exact same database. However, their data is strictly and virtually isolated. So to the tenant, it perfectly appears as though they have their own private sole-use system. To understand how that magic actually works, check out how a single database handles multiple companies using a tenant identifier key. A specific key like 234 belongs strictly to XYZ Corp, while key 435 belongs to J. Bowie. By tagging every single piece of data with this key, the system can virtually isolate the entries. When a user from XYZ Corp logs in, the system filters the database and only shows them rows tagged with 234. It's brilliant and highly, highly efficient. Our third and final architectural factor is scalability. This is simply the ability of the system to cope with an increasing number of users without slowing down or crashing. Now, in the context of SaaS, when we say scalability, we usually mean scaling out by adding more servers horizontally to handle the load, rather than scaling up by just cramming more RAM or a bigger processor into one single server. To handle unpredictable spikes in user traffic, your textbook gives us these golden guidelines. First, utilize simple stateless services, meaning the server doesn't need to remember past interactions to process a new one, making it super easy to share the load across many servers. Second, use asynchronous interactions. This simply means the application doesn't freeze up while waiting for a database result. It lets the user keep working. You also want to manage your resources as a shared pool, allow fine-grained locking on your database so you only lock specific rows being edited rather than locking the whole database, and finally, rely on a robust platform as a service, or PaaS, like Google App Engine to automate this entire scaling out process. Moving on to Part 5, the Chapter 17 Master Recap. Let's lock in those key points. Here is your master recap. You absolutely need to memorize these concepts. Know the 3 main benefits of distributed systems: scalability, resource sharing, and fault tolerance, which just means if one server dies, the whole system doesn't collapse. Be able to list the 4 logical client-server layers: presentation, data handling, application processing, and the database layer. And finally, be very familiar with the major architectural patterns: master-slave, thin and fat clients, multi-tier, distributed component, and peer-to-peer networks. Seriously, memorize this framework, it's foundational. Finally, Part 6, Summary and Exam Focus. Let's go over your final preparation checklist. When you sit down for that paper, make absolutely sure you can do the following: define SaaS and list its business benefits and drawbacks, clearly and decisively contrast SaaS with SOA, define the big 3 architectural factors: configurability, multi-tenancy, and scalability. And finally, and this is such an easy way to optimize your marks, remember to check your spelling. Use South African English spelling in your answers. For example, words like program, behavior, customize, and optimize all need to be spelled correctly according to our local standards. Don't throw away easy points. And that brings us to the end of our chapter explainer. Please don't forget to print you study guides using the new paper-cut system right here on the Midrand campus so you have them on hand for your final review sessions. Keep pushing hard, study smart, and I wish you the absolute best of luck for the assessment week from September 5th to the 9th. But before you go, I want you to think about this. As network speeds eventually approach near instantaneous global coverage, will local software installations completely cease to exist in our lifetime? Ponder that as you review your notes. You've totally got this. See you next time.